Hi students, now let's learn about the redox reactions. In a redox reaction, one substance gets oxidized and the substance gets reduced. So a redox reaction is a reaction in which one compound is oxidized and another compound is reduced. But what does the oxidation and reduction mean? As per the classical concept of oxidation and reduction, oxidation is the addition of oxygen, or it is the addition of an electronegative element. Suppose we take certain reactions here. A magnesium reacts with the oxygen. Addition of oxygen to the magnesium, so this is oxidation, which means that magnesium is getting oxidized. Similarly, the sulfur is also oxidized because sulfur gets an oxygen, forms sulfur dioxide. So addition of oxygen or any other electronegative element is called oxidation. Suppose we add the fluorine to the magnesium, chlorine to the magnesium, sulfur to the magnesium. All these reactions are the addition or the oxidation reactions. So here an electronegative element adds to the magnesium, therefore this is an oxidation reaction. Another definition of oxidation is removal of hydrogen. If you remove the hydrogen, that's also oxidation. If you remove not only hydrogen, any electropositive element, that is again the oxidation. So let's take an example here. H2S, let's remove the hydrogen. If you remove the hydrogen from the H2S here, correct, so therefore the sulfur gets oxidized. Okay, you remove the hydrogen here, so that means iodine is getting oxidized, right? So HI oxidized to the I2, H2S oxidized to the sulfur. So oxidation is addition of oxygen or any other electronegative element, or it is the removal of hydrogen or any electropositive element. Now what about the reduction? Reduction is opposite, right, to the oxidation actually. Addition of hydrogen is reduction. Addition of oxygen is oxidation, but addition of hydrogen is reduction. Okay, so if you add the hydrogen, that is reduction, or if you add any electropositive element, that is also reduction. Suppose here in this example you are adding the hydrogen, breaking a double bond, get a single bond there. Addition of hydrogen is reduction. So again here addition of oxygen is addition of hydrogen is reduction. Or the other definition is removal of oxygen. If you remove the oxygen or if you remove any other electronegative element from the substance, that is reduction. Suppose we have HgO. Remove the oxygen from here, and what you find, the HgO changes into the mercury. So removal of oxygen is reduction. Or removal of any electronegative element. Suppose we have HgCl2, mercury with 2 chlorine atoms. Now if you remove the one chlorine, you get one mercury with one chlorine atom. Okay, so removal of electronegative element, that is again reduction, and that chlorine goes to SnCl2, which forms SnCl4. So that means what? This SnCl2 gets oxidized because SnCl2 changes into the SnCl4. Here we find addition of electronegative element. So addition of electronegative element is oxidation, removal of electronegative element is reduction. So this is getting reduced, so this is the reduction and this is oxidation. So as per the classical concept, if we try to summarize what does the oxidation and reduction mean to avoid any confusion, so let's try to summarize what does the oxidation actually mean from the classical concept. And what does the reduction actually mean? Let's try to summarize what is the oxidation reduction, what we so far studied. As per this classical concept, it says addition of what? Addition of oxygen or electronegative element, right? Electronegative element. Addition of oxygen or electronegative element is oxidation, or you can say removal of hydrogen or electropositive element, that is oxidation. And what is reduction? This is the addition of hydrogen or addition of any electropositive element, or removal of oxygen or electronegative element. Correct? Oxidation is addition of oxygen or any electronegative element, or removal of hydrogen or removal of any electropositive element. Correct? So if you add the oxygen, it is oxidation. If you remove the hydrogen, so let's say the plus sign for the addition and negative sign for the removal. So plus oxygen, addition of oxygen is oxidation, loss of hydrogen, that is again oxidation, right? Addition of hydrogen or loss of oxygen, both are reductions. Correct? Fine. Now the oxidation can only occur when reduction is possible. You know, the two reactions, oxidation and reduction, actually these are the two half reactions of a redox reaction. Redox reaction is a reaction where one substance is oxidized and another substance is reduced, which means that oxidation and reduction can go side by side, hand in hand only. Okay, oxidation is only possible when reduction is possible. One substance gets oxidized only when another gets reduced. Correct? Fine. Like in this example, the zinc oxide reacts with the carbon, form a zinc plus oxygen. What we find here, oxygen is lost from the zinc oxide and it changes into zinc. So here in this step, zinc oxide loses oxygen, so loss of oxygen is called reduction. Okay, loss of oxygen is called reduction, and addition of oxygen is called oxidation. Carbon gets oxygen, so forms carbon monoxide, therefore this is oxidation, which means oxidation is only possible when reduction is possible. Correct? Oxidation can occur when reduction is possible there. So that's why the oxidation reduction go side by side. Another example here, suppose H2S. From H2S, if I remove the hydrogen here and change it into the sulfur, so loss of hydrogen, right? Loss of hydrogen, again that's also called oxidation. Correct? Now bromine, it changes into HBr, that means hydrogen adds to the bromine. Addition of hydrogen is called reduction. So oxidation and reduction go side by side. The modern concept about the redox reactions is based on the electron concept, right? So electronic concept, on the basis of electronic concept, we say the oxidation is basically the loss of electron. This is actually a modern concept, right? And this is based on in terms of electron transfer. You know, when one substance loses electron, another substance gains. So that is actually a redox reaction, a reaction in which one substance is losing electron, another gains. So that means this is a redox reaction, and the loss of electron is called oxidation, right? And the gain of electron is called reduction. So oxidation is loss of electron and gain of electron is reduction. Let's take here an example. Suppose if you have a sodium, it changes into the sodium plus, and electron loses electron here. So this is an oxidation. And suppose the chlorine, if it accepts electron, form a Cl negative, gain of electron, that's called reduction. correct? So that means if you react the sodium and the chlorine and there is transfer of electron from sodium to the chlorine, it changes the sodium into sodium plus and chlorine to Cl negative. This is basically a redox reaction where sodium is getting oxidized and chlorine is getting reduced. And this is a redox reaction. Similarly, let us take another example here. Suppose if I react the zinc with a copper sulfate solution. So what will happen here? The zinc changes into the zinc 2 plus ion and forms the zinc sulfate solution plus copper. So copper sulfate actually has a plus 2 charge here, copper, and the sulfate is 2 negative. So what we find in this reaction, zinc loses electrons and the copper gains. So when the zinc loses electrons and forms zinc 2 plus, so therefore this is loss of electron, which is called oxidation. So that means zinc gets oxidation, undergoes oxidation, copper gains and forms the neutral copper, right, the solid copper. So gain of electron is called reduction. So if you take the zinc rod in the copper sulfate solution, zinc will change into zinc sulfate and you get a deposition of a copper. It's like this. Suppose if you take a beaker here containing the copper sulfate solution, containing a copper sulfate solution, right, and in this copper sulfate solution, suppose we insert the zinc rod here. The zinc rod is here now. If you take the zinc rod in the copper sulfate solution, you will find that after some time the zinc rod, you will see the weight of the zinc rod here decreases because the zinc rod dissolves in it. Okay, the zinc rod dissolves in it. So therefore the weight of the zinc rod will decrease and you will find some copper here getting deposited at the bottom. You get a precipitation of a copper. Why? Because in this reaction the zinc changes into zinc 2 plus electrons, which means the zinc loses electrons and the zinc ions go into the solution. Electrons, they react with the copper ions from the solution and form what? Copper ions accept electrons, zinc loses electrons, copper ion accepts and form with the solid copper. The precipitation that you find here, this is actually the copper. And the blue color of the solution, the copper sulfate has a blue color solution. You will see that with time it fades, it decreases, the color will fade and the weight of the zinc rod will also decrease because the zinc rod will dissolve in the copper sulfate solution. So that means zinc undergoes oxidation and the copper undergoes reduction here. Overall reaction is zinc reacts with the copper sulfate solution and forms the zinc sulfate plus copper, right. This is the redox reaction, and every redox reaction actually consists of two half reactions. One is oxidation half reaction, this is the oxidation half reaction, and this is the reduction half reaction. Oxidation is possible when reduction can occur, right. So that's why they go hand in hand. Hope you got the concept. Thanks for watching the video. Bye.